Hey everyone, this is how we're going to solve literal equations. So, given a literal equation, which is an equation that's about something, say area equals 1/2 base times height, I'll ask you to solve for a variable. In this case, we're going to choose b. Currently, we're solved for a. We want to solve for b, so we have to move our equation around to be able to do that. We're not getting rid of anything really, we're just adjusting it. So there's a couple ways to do this. First is a flowchart. We start with the variable we want to solve for. Find out the first thing that's happening to it. So let's say times 1/2 and times h. You could have done that as the same step if you'd like, but you'll see in a second why I chose to split that up. So you have 1/2 base times height, and that's going to equal your area. So area equals 1/2 base times height. Now on the way back, we're going to use our inverse operations. The first thing that we are going to do here is divide h, right? The inverse operation of multiplication, division, a over h. So now here we've multiplied by 1/2. And we know from class that we multiply by a fraction. To reverse that, you multiply by its reciprocal. So we're going to multiply by 2. So we're going to get 2a over h. Just remember for your fractions, it's 2 over 1 times a over h, and then we're multiplying across. So 2a over h. And that should give us our final answer of what b is. So b is 2 times the area over the height. So all we've done here is make our equation from solve for area to solve for the base. We've just moved things around in our equation so we can solve for the variable that we want. I'll show you why in a couple slides. Next, y equals mx plus b, solving for x. So again, we could solve with our flowchart. Start with x. We can multiply by b. So we have mx. So first thing I have to do it, multiply by x, and then we're going to add b. Mx plus b, and that should equal y. Y equals mx plus b. Now on the way back, inverse operation of plus b is minus b, y minus b, and then divide by m. And we're going to divide everything by m. So whenever in this last step we're multiplying or dividing, we're doing it to everything. Everything that we've had so far, we are multiplying or dividing it by. And that's going to equal x. So x equals y minus b over m. And for simplification purposes, we're going to split this up and say x equals y over m minus b over m, which we're allowed to do because it have the same denominator. So, let's try this a different way. Say I just gave you y equals mx plus b. Told you to solve for x, and you just don't like flowcharts. Let's solve for x without using a flowchart. So we have to move the furthest thing away first, subtract b. Just like we would any other problem, where we would do subtraction first, and then our multiplication division second. So y minus b equals mx. Divide by m. You get x equals y minus b over m. Notice the exact same thing that happened here. We subtracted b first, it's the same as the way back. Divide by m second, and then put it into our formula. And again, we'll simplify in the end. And get the exact same answer. So you have either of these options. You can either use a flowchart or solve in the traditional method. Just remember, you cannot combine unlike terms. So when I subtracted b from here, y minus b is just y minus b, because y and b are different variables. Let's move on. F equals ma. Force equals mass times acceleration. And we're going to solve for m. So let's just try this the traditional method. So F equals ma. And we want to get m alone. So the only thing that's happening to m is that it's multiplying by a. If we divide by a on both sides, using our inverse operations, we get m equals f over a. Right? That's it. Nothing big happened there. So now we're given that the force is negative 1,240 newtons, and the acceleration is negative 9.8 meters per second squared. So the reason we did this, the reason we solved it for m, is that we knew the force, we knew the acceleration, but we didn't know the mass, and that's what we wanted to solve for. So the whole point is to isolate the variable that we want to solve for. So now we can plug in. So mass equals negative 1,240 over negative 9.8. And if we use our calculator, we get that it weighed 126.5. Okay, so this is all we had to do here. We solved for our variable first that we wanted to solve for because we knew what our force was, we knew our acceleration, but we didn't know the mass. So we solved for m, plugged in, and all of a sudden there came our m. So let's move on. Volume of a cone. The volume is 1/3 pi r squared h. In the more complex problems, we might want to try a flow chart. So we'll start with that. Start with the variable h. We're multiplying by 1/3, so we have 1/3 h. We're multiplying by pi. Let's just do pi r squared in the same step because it's all really multiplying, so why not just do it all together? 1/3 pi r squared h. So when we're all multiplying, you can do it as one step. The only thing I'd recommend is if you have a fraction on the outside, to do it as its own step. That way you can remember to do the reciprocal. And that's going to equal v. So v equals 1/3 pi r squared h. On the way back, start with v. If we multiply here, we're going to divide here. So v over pi r squared. And the reason we put this out on its own is so that we can use the reciprocal and multiply by 3. So 3v over pi r squared. And that's equal to h. h equals 3v over pi r squared. Since there's nothing being added or subtracted here, we do not have to split it apart. So let's try the traditional route. So we're seeing all of this happening to h. Pi r squared is multiplying and 1/3 is multiplying it. So let's divide by pi r squared first. V over pi r squared equals 1/3 times the height. Multiply by the reciprocal, times 3, times 3. So we have 3v over pi r squared equals h. And this is our formula. Now solve for the height, which is what we didn't know, because we are given the volume, we're given the radius, but we don't know the height. So let's plug it in. We have 3 times 400 over pi times 8 squared equals the height. And this is where the calculator becomes very useful. And we get a lot of plugging in here, 5.97 as our height. So the real value here for literal equations is once you solve for the variable you're looking for, all you have to do is plug in and plug this into your calculator as is, and you come out with your answer. So just make sure when you're using the calculator, you put parentheses around the numerator and denominator, the whole thing. All right.